Welcome to the last part of Earth geometry. So far we've looked at Earth as a sphere, position of a point, we looked at distance along small circles and distance along great circles. Here we're going to take a look at the concept of speed and time. So whenever we're talking about distance, the concept of speed and time should come in also. We have learned how to calculate the distance between points. So now it's time to calculate speed and time. So speed is usually calculated using nautical miles, not kilometers, because this is a standard that people in navigation who fly from one point to another use. So speed is distance over time, the same old formula, but the distance should be nautical miles and time should be in hours. The units of speed when you use distance in nautical miles and time in hours is knot. So these are next we look at time. So time, it is all about being able to calculate time on different parts of the earth. So the earth rotates such that it turns 360 degrees in 24 hours. When we divide it 360 by 24, we discover that 15 degrees movement on the earth is equal to 1 hour. So if a point has rotated by 15 degrees, it means it has moved for 1 hour. So this line, the prime meridian or the Greenwich, which is the longitude 0 degrees, is used as the center for time measurement. So all the time in the world are calculated based on the time here. By that I mean, if they want to find the time here, we have to do some mathematics that is based on the time here. So this prime meridian or Greenwich is called the universal. The time at Greenwich is called the universal time. It's called the Greenwich Mean Time, GMT. So whenever they say it's 2 GMT, just know that this is the universal time or the time at the Greenwich meridian. So every 15 degrees east movement adds 1 hour to GMT. So east is to the right, west is to the left. So any 15 degrees this direction, it adds 1 hour to this. So if we have it's 12 hours here, then if the difference between here and here is 15 degrees, then it's 13 hours here. If the difference between here and here is 30 degrees, which means there are 2 15 degrees in there, then it's going to be 14 hours here. Every 15 degrees movement to the west subtract 1 hour from GMT. However, movement this direction will remove 1 hour. So if the difference between here and here is 15 and here is 12, mean that here is 11. Then if here is 30 degrees west, mean that there is 15 degrees difference, you subtract 2 hours, 1 hour, 1 hour. So here it's going to be 10 hours. So that's how to calculate time. You just need to know the time at the GMT or at the prime meridian. Then depending on the side or on where the point is, if it is on the west, you subtract from the time at GMT. If it is on the east, you add. So there's this question: Chainama is 45 degrees east and Kabuma is 55 degrees west. What is the local time in Chainama and Kabuma if it is 1320 hours GMT? So they have given us the GMT time. Now they want the local time in Chainama and Kabuma. So what is important, GMT, is to know that GMT is at 0. So at Chainama, they have said it's 45 degrees. We're going to start with the Chainama case, which is here Chainama case. So we know that 1 hour is equal to 15 degrees, but here it's 45 degrees. So X hours is equal to 45 degrees. In short, how many hours are going to be equal to 45 degrees? So when you do cross multiply, we're going to get 3 hours. These 3 hours should be since Chainama is on the east, should be added to 1320. So with that, of course, I got these numbers by cross multiplying. So of course, at GMT is 1320, so we add the 3 hours that we got here and we get 1620. So adding is not difficult. 13 hours plus 3 hours, 1620 minutes plus 0 minutes, it's 20. But sometimes when you're adding, it can happen that, let's say you are 20 and you're 50. So 20 plus 50 to give you 70 minutes. From 70 minutes, you can remove 60 minutes, which makes up an hour. Then you add to the number you're going to get when you add the hours. Then the remainder of the minutes are the ones you're going to indicate. Okay, let me just say that again. Let's say this was 1320, and let's say you had found 3 hours 50 minutes. So when you start with the minutes, it's going to be 20 plus 50 to give you 70. So we can't write 70 minutes. We know that 60 minutes is 1 hour. So from 70, we're going to remove 60, and we're going to remain with 10, and we're going to write 10. Then that 1 hour, which is equivalent to 60, the 60 that we had removed from 70 is 1 hour. We're going to add to the what we're going to get when you add hours. That is 13 plus 3, 16 plus that 1 hour is going to be 17. We go to the Kabuma case. So for the Kabuma case, it is at 15 degrees west. West we subtract. So again, we're going to see how many hours are equivalent to 15 degrees. So we're going to say 1 hour is equal to 15 degrees. X hours is equal to 55. So when you do cross multiply, we're going to get 15x equals 45 divided by, before we divide, just trying to show you that here what I did is x times 15 and 1 times 55, or 55 times 1. That's how I got 15x 45. So now I can divide by 15 both sides. I'm going to get 3.67 hours. Now this is a trick number, 3.67 hours. We know the 3 is hours. What about 6.7.67 in short, or 0.67? So this has to be converted to minutes. So how do you convert? You just multiply it by 60. So in short, this you can break it apart to be 3 hours plus 0.67. Then you can multiply this 0.67 times 60. You're going to get 40 minutes. So these 40 minutes, it means that this is 3 hours plus 40 minutes, or 3 hours 40 minutes. Now the next job is from 320, since this is west, we have to subtract 3 hours 40 minutes. So this is also something we need to be careful. So what you do is you say 20 minus 40. You subtract as a whole. Don't do 0 minus 0, 2 minus 4. No, you subtract as a whole. That is the minutes from the minutes, then the hours as they are from the hours. 20 minus 40. You cannot subtract 20 from 40. So what we're going to do is we're going to borrow from here. So we're going to borrow 1 hour from here. So this is going to become 12, since we have removed 1 hour. When this 1 hour is taken to the side of minutes, it's going to be 60. So on the minutes, we're going to have 60 plus what is already there. So 60 plus 20 is going to be 80. 80 minus 40 is going to be 40. And 12 minus 3 is going to be 9. So this is going to be 9 hours 40 minutes. That is the local time in Kabuma.